right. So today we're diving into something pretty spectacular.
Yeah.
The science behind rainbows.
I love rainbows.
You and everyone else.
Yeah.
You've said over some really fascinating points about rainbow chemistry.
Oh,
And I'm ready to have my mind blown.
Okay, well, get ready.
Okay.
We're about to unpack how those mesmerizing arcs of color actually form.
Mm-hmm.
We'll be exploring the interaction of light and water droplets.
Okay.
The bending of light known as refraction, dispersion,
Yeah.
and even touch on some other atmospheric optics.
Okay, cool. So first things first, rainbow chemistry.
Okay.
How exactly does light interact with those tiny water droplets?
So imagine this. A beam of sunlight hits a raindrop.
Okay.
Now, instead of just passing straight through, that light gets bent
Okay.
as it enters the denser water droplet.
Right.
That's refraction.
Refraction.
In action.
So it's like when you put a straw in a glass of water
Yes.
and it looks all broken.
Exactly.
Right.
But here's where things get really mind-boggling.
Okay.
Once that light is inside the droplet, it doesn't just stop there. It bounces off the back surface of the droplet.
Yeah,
So the reflection...
So it's like a miniature game of late ping pong
Precisely.
that's happening inside each raindrop.
Exactly. But wait, there's more.
Okay.
Remember, white light
Mm.
is actually a mixture of all the colors of the rainbow.
Mm-hmm.
And during this process of refraction and reflection, something amazing happens.
It splits, like
Yeah.
when you shine a light through a prism.
You got it.
Yeah.
That's dispersion.
Dispersion.
And it's happening inside each raindrop.
Whoa.
Each color of light bends at a slightly different angle,
Okay.
creating that distinct separation of colors we see in a rainbow.
So to recap, we've got light entering a raindrop. It's bending,
Yep.
bouncing off the back,
Uh-huh.
and then splitting into colors.
Yes.
What happens next?
Okay.
How do these colorful rays of light actually become that stunning arc in the sky?
Well, as that separated light exits the raindrop, it gets refracted yet again.
Okay.
And this time, the separation of colors becomes even more pronounced.
Oh.
Because each color exits at a slightly different angle,
Right.
they reach your eye at different positions,
Oh,
forming that iconic arc.
wow. It's incredible how these simple processes
I know.
can create something so visually stunning.
Right.
And what's even cooler is that this precise bending of light
Yeah.
means the angle of the rainbow is always 42 degrees.
Oh,
From
yeah.
the anti-solar point,
It's true.
the point directly opposite the sun.
Yeah.
Talk about a fun fact to drop at your next cocktail party.
Absolutely. But rainbows are just one example of the wonders
Oh,
of
wow.
atmospheric optics.
Okay.
The study of how light interacts with our atmosphere to create all sorts of visual phenomena.
You mentioned other atmospheric optics.
Yes.
What else falls under that umbrella?
Oh, there's a whole world of fascinating phenomena out there.
Okay.
We've got halos around the sun or moon sundogs,
Uh-huh.
light pillars,
Okay.
glories, and those are just a few examples.
Hold on, sundogs.
Yes.
I think I've seen those before.
You probably have.
Those bright spots of light
Uh-huh.
that flank the sun.
Yep.
Especially in cold, icy days.
You're exactly right. Those are sundogs.
Okay.
And just like with rainbows, they're formed by the interaction of light and ice crystals in the atmosphere.
Interesting.
The ice crystals act like tiny prisms,
Okay.
refracting and dispersing the sunlight,
Wow.
creating those dazzling spots of color.
So basically the same principles of light interaction are behind all these amazing atmospheric optics.
It is.
Whether it's water droplets or ice crystals,
Precise.
it's actually blowing my mind.
It's pretty cool.
It's like the atmosphere is putting on this incredible light show,
Yes.
and now I finally understand the science behind the magic.
And there's still so much more to uncover.
Oh, no.
From the ethereal glow of glories to the shimmering colors of halos.
Okay.
Each phenomenon offers a unique glimpse into the interplay of light and matter.
Well, I'm definitely hooked.
Right.
Let's delve deeper into some of these other atmospheric optics.
Okay.
After a quick break to let this all sink in, stay tuned because the light show's just getting started.
All right, welcome back. I'm eager to delve deeper into these atmospheric optics.
Okay.
And we were just discussing sundogs.
Right.
But what about halos?
Okay. Yeah.
You mentioned seeing them around the sun, especially on hazy days.
Yes. I always thought they were just a simple ring of light, but now I'm wondering if there's more to them than meets the eye.
There's definitely more than meets the eye.
Okay.
Halos, like sundogs, are created by the interaction of light with ice crystals.
Mhm.
But instead of appearing to the sides of the sun,
Yep.
halos form a complete ring or circle around it, or even the moon.
And they often have those mesmerizing iridescent colors, too.
Absolutely.
Yeah.
Just like with rainbows and sundogs, those vibrant colors are due to dispersion.
Uh-huh.
The way light splits into its different wavelengths as it passes through those ice crystals.
So the principle is the same, but the arrangement of the ice crystals is different.
Precisely.
Okay.
It's fascinating how the shape and orientation of those tiny ice crystals determine the specific type of halo that forms.
Okay.
There are actually many different types of halos, each with its own unique look.
Wow, I had no idea. I always assumed a halo was just, well, a halo.
There are circular halos, elliptical halos, tangent arcs. There's even a stunning phenomenon called a circumzenithal arc, which is a colorful upside-down arc that appears high in the sky with a celestial smile.
An upside-down rainbow smile. I need to start paying more attention to the sky. What else should I be looking for?
Keep an eye out for glories.
Glories.
Those are colorful rings of light that you sometimes see around the shadow of your head when you're looking down from a high vantage point, like a mountain peak or an airplane.
Wait, are you telling me my shadow can have a halo?
In a sense, yes. It sounds mystical, but glories are actually formed by a special kind of reflection called backscattering, where sunlight interacts with water droplets in clouds or fog.
Backscattering, so that's different from the simple reflection we talked about with rainbows.
That's right. Imagine a disco ball scattering light everywhere versus light reflecting off a smooth mirror.
Okay.
That's the difference between backscattering and typical reflection.
Okay, I get it. So how does this backscattering create those colorful rings around a shadow?
Those light waves, after bouncing around inside water droplets, actually interfere with each other.
Okay.
Remember constructive and destructive interference?
Yeah.
Some colors get amplified while others get canceled out, depending on the size and distribution of the water droplets.
So it's interference again, but this time it's not from thin films like soap bubbles, but from light scattering within water droplets.
Exactly.
Right.
It's amazing how these same principles of light interaction can create such diverse and visually stunning phenomena.
It really is, and it makes me wonder, we've been focusing on sunlight, but could moonlight create these effects too?
Absolutely. Moonlight is just reflected sunlight, so it can create all the same effects, but on a smaller, fainter scale.
Okay.
You could theoretically see a moonbow, for example, though they're incredibly rare and difficult to spot.
Oh, moonbow, I'm adding that to my bucket list. So to sum it up, it's all about the interplay of light and matter refraction, reflection dispersion, and inference, creating this breathtaking display of atmospheric optics.
Precisely. And we can't forget the role our own perception plays in all of this.
Right.
The way our eyes and brains process light adds another layer of complexity and beauty to these phenomena.
And you're right, the colors we perceive are influenced by how our eyes and brains interpret those light signals. It's not just about the physics, it's about the biology of our senses as well.
Exactly. And that highlights the incredible interconnectedness of different scientific disciplines.
Yeah.
To fully understand the world around us, we need to consider physics, chemistry, biology, even psychology.
It's like this intricate web of knowledge, and the more we explore it, the more we realize how much there is to discover.
Beautifully put. And speaking of discoveries, what if we could recreate these atmospheric optics artificially? Could we bring the wonders of the sky down to Earth?
That's a fascinating thought. Is that even possible?
To some extent, yes.
Okay.
Think about rainbows. We know they're formed by the interplay of light and water droplets.
Uh-huh.
So if we create a controlled spray of water droplets and illuminate them with the right kind of light, voila, we can produce a rainbow.
Like those rainbow sprinklers you see in gardens.
Exactly, and we can apply similar principles to other phenomena.
Okay.
Researchers have created artificial halos and sundogs using glass beads or prisms to mimic the effect of ice crystals.
So we can essentially hack the physics of light to create these wonders on demand.
It's fascinating how our understanding of these natural phenomena allows us to not only appreciate their beauty,
Right.
but also harness their principles for innovation. Think lasers, fiber optics, holographic displays, all rooted in our understanding of light.
That's incredible. Like, we're taking the secrets of the sky and applying them to our everyday lives.
What's important to remember is that this dance between light and matter is happening constantly all around us, enriching our world with visual complexity and beauty.
Well said. It makes you realize that science isn't just about abstract knowledge. It's about understanding the world so we can interact with it in new and creative ways.
On that note, I think we've covered an impressive amount of ground today, from basic light interaction to the nuances of human perception.
Yeah.
But before we get carried away with dreams of future optical inventions,
Right.
let's take a moment to gather our thoughts and wrap up our deep dive with some final reflections.
I agree. Let's take a moment to soak it all in when we come back. I'd like to leave our listeners with some final thoughts and perhaps a few questions to spark their own explorations into the world of atmospheric optics.
Welcome back to the deep dive. It's been quite a journey today, hasn't it?
It really has.
From those familiar rainbows to the more elusive glories and halos.
It's amazing to see just how much wonder is packed into a simple ray of light.
Yeah, it's been a real delight exploring this with you.
Yeah,
What stood out to me is how these phenomena, which we often just see as pretty,
right.
can reveal so much about this complex dance between light and matter.
Absolutely, and we can't forget the role our own perception plays in all of this.
That's true.
The colors we see are really a beautiful blend of physics meeting biology,
Yeah.
those light signals being interpreted by our unique eyes and brains.
Yeah, it's a reminder that science isn't just about cold, hard facts.
Mm,
There's an element of personal experience woven into how we understand the world around us.
so true. As we wrap up this deep dive, what are some key takeaways you hope our listeners will walk away with?
Well, first and foremost, I hope they'll never look at an airbow or a halo the same way again.
Yeah,
They're not just beautiful sights.
right.
They're windows into the complex workings of our atmosphere.
It's like the atmosphere is putting on a show, and we've been given the backstage pass to see how it all works.
Exactly. And anyone can be an observer. You
Yeah.
don't need fancy equipment
Right.
or a degree in physics to appreciate these wonders.
Just a sense of curiosity and a willingness to look up.
Precisely. It's a reminder that science is all around us waiting to be explored.
So for our listeners out there, I encourage you to keep your eyes on the sky. Don't just dismiss those fleeting moments of optical magic. Ask yourself why they're happening, what they might reveal about the world around you.
And don't be afraid to dig a little deeper.
Yeah,
Read up on atmospheric optics,
yeah.
experiment with prisms and water droplets, see if you can recreate some of these effects at home.
Maybe even try to capture a moonbow on camera.
Exactly. Embrace that scientific curiosity. You never know what you might discover.
It's been an absolute pleasure exploring the world of atmospheric optics with you.
The pleasure was all mine.
And to our listeners, thank you for joining us on this deep dive into the chemistry of rainbows and the magic of light and water's dance. Until next time, farewell from the deep dive.